Okay, dear students, let us start unit 2, that is shear force and bending moment. Shear force and bending moment. So here, before studying about the shear force and bending moment, let us know what is beams and types of beams. What is beams and types of beams. Now what is beam here? Beam is a horizontal member of a structure carrying transverse load. Here, let us consider a structure. This as a structure. Now, to this structure, it contains vertical members and also horizontal members. Vertical members and also horizontal members. So here, these horizontal members are called as beams, and these all vertical members are called as columns. Okay, so here beam is a horizontal member of a structure carrying transverse load. That is the definition of a beam. And now types of beams. Types of beams. So how many types of beams are there? In the last class I explained about types of beams, types of supports, and also types of loads. In the types of beams there are 5 types. First one is cantilever beam, and the second one the second one is simply supported beam simply supported beam. Third one is overhanging beam overhanging beam. And the fourth one is propped cantilever beam propped cantilever beam. And the fifth one, last one, is continuous beam. So this is about types of beams. So in the last class I explained how many types of beams and also types of supports and also types of loads. Now let us study about shear force and bending moment. So what is shear force and what is bending moment? What is shear force and what is bending moment? Here, write down next heading, shear force. Shear force. Shear force. So its units, its units are Newton or kilonewton. Newton or kilonewton. So what is the definition of shear force? Theoretical definition of shear force is a force that acts parallel to the surface or cross section of a member. Parallel to the surface or cross section of a member is called a shear force. See here, let us consider a beam. Let us consider a beam. Let us consider a beam. And here there is a simple supported. This is a simple supported beam of length L. Of length L. Of length L. So this is the cross section area, right? This is the cross section area, that is B into D. So in this beam, in this case you can see only the length of the beam, then it is called as longitudinal section. Here you are seeing only width and depth. In this case you can't see the length of the beam. So this is called as cross section of a beam. Now if the applied load should be a parallel to this cross section area. See here, if the applied load is parallel to the cross section area or parallel to the surface of a cross section area, then it is called as shear force. See, if you apply a load perpendicular to the cross section area, see, this is perpendicular to the cross section area, this is cross section area, and if you apply a load perpendicular means that is not a shear force. Okay, only when you apply a load that is parallel to the cross section area or to the surface of a cross section, then that is called as shear force. So the definition is shear force is a force that acts parallel to the surface or cross section of a member. It is called as shear force, and the units of shear force is Newton or kilonewton. Now what is the mathematical definition? Mathematical definition of shear force. Mathematical definition of shear force. Mathematical definition of shear force mathematical definition of shear force. Okay, so mathematical definition of shear force. Shear force at a point. Shear force at a point. Shear force at a point, or shear force at a section. Shear force at a section. So that mathematical definition of shear force is algebraic sum of all vertical forces. Algebraic is algebraic sum of algebraic sum of all vertical forces either to the left or to the right side of a section. Algebraic sum of all vertical forces. Algebraic sum of all vertical forces either to the left, either to the left or to the right side of a section So this is the mathematical definition of shear force. Now let us understand the definition. See here, consider a beam. Consider a beam. This is a beam. This is the beam. Here it is a simply supported RA, RB, and it is subjected to a point loads. It is subjected to a point loads W1, W2 and W3. Now consider one section or one point. Okay. Now considering a section XX or at a point XX, in order to find the shear force, we can find in two forms. One is shear force at section XX from left side. From left side. From left side. Left side means this part, right? So shear force at X is equal to RA plus RA because the load is acting vertically upward minus W1 because the load is acting vertically downwards. So the left side of a section XX there are two forces. So one is plus RA minus W1. This is shear force at section XX from the left side. Next, shear force at section XX from right side. From right side. So how we will calculate? Shear force at section X is equal to plus RB minus W2 minus W3. So in two forms we can calculate the shear force, that is either from the left side or to the right side of a section. That is the theoretical definition of a shear force. Now what is bending moment? What is bending moment? So here write down bending moment. Bending moment, bending moment, kilonewton meter or newton mm. Units of bending moment is kilonewton meter or newton mm. So here the definition of bending moment is due to rotational effect in a member. If bending occurs, then it is called as bending moment, or it is a measure of rotational effect. Okay, due to rotational effect in the member, due to rotational effect, due to rotational effect in the member, in the member if bending occurs, if bending occurs, if bending occurs, then it is called bending moment. Then it is called bending moment. So this is the definition of bending moment, and mathematical definition of bending moment is mathematical definition of bending moment. Mathematical definition of bending moment. Algebraic sum of all the moments either to the left or to the right side of the section. This is also same as I explained in the shear force mathematical definition of shear force. In the same way, algebraic sum of all the moments either to the left or to the right side of a section. So in bending movement, again we have two types. In bending movement, again we have two types. One is positive bending moment, positive bending moment, positive bending moment, and the second one is negative bending moment. Negative bending moment. Negative bending moment. So here, what is positive bending moment? What is positive bending moment? If the deflection is in downward direction, if the deflection is in downward direction, then it is called as positive bending moment. If the deflection is in downward direction, what is the positive bending moment? So let us consider a simple supported beam. This is a simple supported beam. This is a simple supported beam. Reaction RA, RB, and it is subjected to some loads. Okay, whatever it may be, a concentrated load, or it may be a UDL load. So due to a load, there will be a downward deflection. There is a downward deflection in the beam, right? There is a downward deflection in the beam, that is concave curve in upward direction. This is the concave curve in the upward direction. So this type of deflection is called as sag curve. Sag curve, sag curve, and positive bending moment. Positive bending moment. If the deflection is in the form of sag curve, then it will be called as positive bending moment. So here, what is negative bending moment? Negative bending moment. If the deflection is in upward direction. So if the deflection is in upward direction, then it is called as negative bending moment. So here the best example is cantilever beam. Cantilever beam. So here one side is fixed, the other end is free. In the case of cantilever beam, one side is fixed and the other side of a beam is free. Now the end side of a beam which is free applies certain amount of load, concentrated load, then the deflection will be in this form. Deflection will be in this form. So here the curve is called as hogging curve. This type of curve is called as hogging curve, and the concave curve is in downward direction. Concavity is in downward direction. So this is hog curve, and it is called as negative bending moment. Negative bending moment. So always keep in mind, if the deflection is in downward direction, so that elastic curve is called as sag curve, and also positive bending moment. If the deflection is in upward direction, then it is called as hogging curve, and the bending moment is negative bending moment. So this is about positive bending moment and negative bending moment. Okay.